Okay, today's the third month, third day. In chapter 8, things you will need to know and apply. Chapter 8 dealt with right triangles. The first thing we covered in this chapter was the relationships that exist when you draw the altitude to the hypotenuse of a large right triangle. In the big triangle, it is a right triangle. Notice here that I have the symbol showing this is a 90-degree angle. A is one of the legs. B is the other leg. C is the altitude drawn to the hypotenuse. And X and Y represent the two pieces of the hypotenuse that have been created by that altitude, where it intersects here. Okay? Now, we said there were three similar triangles that were formed, and these are the relationships that exist. It dealt with geometric mean and proportion. We said the long leg of the right triangle is the geometric mean between the long segment created and the entire hypotenuse. That's one of the relationships. These can be used when we're looking for measures of side lengths or segment lengths, and we know that this is the altitude of a right triangle drawn to the hypotenuse. If we use B, we said B, the short leg of a right triangle, or shorter leg. I don't want you to get confused thinking it's a 30, 60, 90. The shorter leg is the geometric mean between the short segment formed and the entire hypotenuse. And then the altitude itself, which is located inside the right triangle, that is the geometric mean between the two pieces that it breaks the hypotenuse into. Now, these are all the relationships that exist with all these pieces. Now, you're not going to have all these pieces. You're going to be given 2 out of 3 pieces of information, and you're going to have to decide which one of them to use. Okay? And you can find practice for that in the Chapter 8 chapter test. The next thing we learned in that chapter was the Pythagorean theorem. You need to know when to use it, how to use it. I will accept radical answers or decimal answers. So whichever you're more comfortable with. Now, the reason I wrote it in this order is because we also covered in this section how to use the Pythagorean theorem to classify triangles. If you recall, we used it in order to tell whether a triangle was acute, obtuse, or right, where C represents the longest side of the triangle. If you recall, when we went to figure out what type of triangle something was, there was a little test we had to do to make sure that these sides could even make a triangle. Does anybody remember what it is?
You add the 2 smaller sides together, and if they're greater than the 5.
Okay. They have to be bigger than the third side. The 2 smaller sides have to add up to be bigger than the third. If you recall, when we were doing this lesson, I actually drew some lines, and we used a ruler to measure them. And we showed that if that was not true, you could not even connect them. They weren't long enough to close up and make a triangle. All right, so this wouldn't even be a triangle, would it? Because 2 plus 3 is not bigger than 5. All right? Okay. The other thing we learned was special right triangles. The first one was our 30, 60, 90. Now, you don't have to use this information. You can use sine, cosine, or tangent functions if you can't remember this. But this saves you a lot of time if you can remember this. So just as a refresher, in a 30, 60, 90, we have a short leg, we have a long leg, and we have a hypotenuse. The hypotenuse, if you recall, is twice the short leg. It is twice as big as the short leg. The long leg is equal to the short leg multiplied by what? The square root of 3. So the short leg is the key. With the short leg, you can find out the hypotenuse or the long leg. But if you're looking for the short leg and you know the hypotenuse, then you will divide by 2. Or if you're looking for the short leg and you know the long leg, you will divide by the square root of 3. So it depends on what you know and what you're looking for. But that's the relationship between those 3 pieces in a 30, 60, 90. Yes? And then we'd have to fix that for the final answer because you can't leave it. All right, in a 45, 45, 90, yes, there are 3 sides to the triangle, but the legs are equal to each other, so we just say leg. The hypotenuse is equal to a leg multiplied by the square root of 2. But if you know the hypotenuse and you're looking for the leg, then instead you will divide by the square root of 2. This should be all already in your brain. All right, and then we also had sine, cosine, and tangent in a right triangle. These are used when it's not a special right triangle. Actually, it can be used whenever. But it's used when we're either looking for side lengths or angle measures and we don't have what we need for the Pythagorean theorem or the special right triangles. Sine of theta was equal to what? Opposite over hypotenuse. Cosine was equal to? Adjacent over hypotenuse. And tangent was equal to? Opposite over adjacent. Now, the hypotenuse is always the hypotenuse. If the angle I have identified right now is my theta, which side is opposite? B. Which side is adjacent? A. Okay? And C is always the hypotenuse. If I change theta to this angle, B is no longer the opposite because in relation to theta, B is now adjacent to theta. And A is opposite of theta. Okay, and then remember when you're using your calculators, if you know the angle measure, you simply hit your sine, cosine, or tangent key. If you're looking for the angle measure, what do you hit first? Your second key or shift key or whatever it is, and then sine, cosine, or tangent. And remember, you need to know how to use your calculator because some calculators are different. Some of them you hit the sine key before you hit the information in. Some of them it's backwards. Yes?
Is the theta ever going to be where the right angle is?
No. The 90-degree angle will never be theta. It's always going to be one of the others. Okay? All right, in Chapter 9, we dealt with circles. Let's refresh our memory on all the things we know about circles. All right, we talked about central angles. What makes an angle central?